Bismillahir Rahmanir Rahim. Welcome to lecture number 10 of CS 325. We will continue our discussion on exploring different operations that we can perform in Pandas library. So in this lecture we will discuss the group by, we will discuss scales, pivot tables, and date functionalities. So let's go to our Jupyter notebook and see the code. So this is our Jupyter notebook. So we continue this code. We'll study group by first. So we have this pandas library and numpy library, and we load the data from census.csv, and we create a data frame where sum level is equal to 50, and we print the df. So let's try to execute it. So it's print the data from the census spreadsheet. Is you see the index, they are numbered from 1 to so on to the number of rows, and there are different columns, the same that we have discussed before. So now let's try to understand the group by. So the group by, let's say we want to process the data. So for state in state name unique, because there are multiple state names that are repeating, so we take it a unique, and then what we compute, np.average df.where df state name is equal to this state with a drop na, it means drop the name values, and which column we perform, census 2010 population, and then we print counties in state have an average population of this. So let's try to execute it. So you see this is executing, so it takes a while and it prints the data for all the states. Now if you want to count how much time it took, so we can run this loop for 10 times and we can time it, we can print the time of this cell in order to understand how much time this operation takes. So you see it's still taking time because the process is executing 10 times. So this demonstrates that this is a very slow process, and we will discuss the new method that can be more efficient than this one. So while this code is executing, let me go to the group function. So we can perform the same operation by using group, comma, frame, in df.group by state name, and what we do, we take the average. Average is equal to np.average and frame census data 2010 population, and we print counties in state group have an average population of this, and you will see this is much faster than this operation. Well, it's already demonstrated that this is taking quite some time, so why not we just interrupt this execution. So we can interrupt it. Let's see if I can stop it. Seems like this is executing. Okay, so it's interrupted. We did not execute it for 10 times, but even if we execute it, let's say one time, and we can see it will give us some error. Okay, it's not giving us error. So we just execute it one times, and we see the time of this cell. It's quite a lot. Still, it's quite a lot. Okay, it seems like it go to another iteration. Still, it's taking time, so you can test it by yourself, but let me interrupt it here. So let's go to this one. The same operation, but we use the group by, and let me try to execute, and it seems faster. And it's the same operation as above. Even if we do the time, and even with the loop of 10 times, I think it's going to be faster. We saw last time with the last operation, the regular operation where we were not using the group by function. It was taking a very long time, even with n is equal to 1. So let me just check it if it takes with n equal to 10, how much time it takes. If it is taking still too long, I mean, it's relatively faster, but still it's a huge operation. So it's taking time. Oh, it's finished. So we see we perform the same operation 10 times. For the previous cell we were waiting for a long time, and we couldn't complete the operation in reasonable time. But this time the operation is completed already, and let me just scroll it down so we can do like this. 262 millisecond with 15.3 per loop. So this is the loop time that it is showing. We can do df.head, and it will print the top 5 attributes, the top 5 rows. And then we can do the sit index, so we keep the sit index as state name. And if item 0 is less than m, so we return 0. If item is less than q, then we return 1, otherwise we return a 2. And then we use the group by function. So for group frame in df.groupby, fun is coming from this function, and there are these many frames records in group for processing. Let's see. So this demonstrates that there are these many records for group 0, and these many records for group 1, and these many records for group 2. So this just demonstrates that how much records we have processed 10 times, and even much faster in just few in 252 milliseconds. Let's do some more operation. So we have df pd.readcsv census.csv data, and we take the data frame where sum level equal to 50. We perform this operation. Nothing happens because we did not print anything. So then we do the group by on the state name with the aggregate function. So we aggregate this data. Aggregation, group by and aggregate, both these attributes you have studied in databases. So in case you don't remember these operations, go to your database book and try to read about aggregate and group by and scale. We are just performing the same operation in pandas library. So here we are using the aggregate as np.average. So you see it's the state name and the average population, that is average on all the states. We can do two. So df.groupby level 0, population estimate 2010 and population estimate 2011, and we can do the type of group by level 0 with the population estimate of 2010 only. So you see these are data frame group by objects. So the first one is data frame group by, and the second one is a series group by. We can do the df.setIndex state name group by level 0 with the census 2010 population, and aggregate average and sum equal to np.sum. This operation is deprecated, but currently it's working, so just go through it and see why it will not work in future. So you see this operation is performed much quicker, and we have both data. Let's say we perform another operation on the two column. So we have df.setIndex state name.groupby level 0, population estimates 2010, population estimate 2011, dot aggregate average np.average and sum np.sum, and we perform this operation. Again, there is deprecation error, but for now you see this is the average, and these are the two columns, 2010 data, 2011, and this is the sum data 2010 and 2011 for all the states. So you see group by is more efficient and useful. We perform another operation. So let's set index df.setIndex state name group by level is equal to 0, population estimate 2010 and population estimate 2011. And for the population estimate 2010, we compute np.average, and for the population estimate 2011, we compute np.sum. Let's perform this operation. So this is data 2010, and this is data 2011. This is average data, and this is sum data. So that was about group by and aggregate functions, how to perform group by operation and how to perform aggregate in pandas. And these are very useful operation. You will see in your project that we commonly perform these operations. Now let's go to a new topic that is called scales. So in scale we have categorical data like grades, because grades are not something that is continuous, it's categorical. So let's say we have a frame, df is equal to pd dot data frame, a plus, a minus. All these are a, but different a. Then we have b plus, b, and b minus. All are b, but different type, different categories in b. And c plus, c, c minus, and d plus, d. I think there should be one fail. So, well, not here, so, but you can put one F as well. So the index with the A grade, this is excellent. With the B grade, it's good, good, good. With the C grade, it's okay, okay, okay. And the D grade is poor, poor. And we rename column with the grades in place equal to true. And let's see. You see, grades are printed because this is column 0 grades, and all the 3 grade, B grade, C grade, and D grade. Now let's print the category. So df grades dot age type category dot head. There is category excellent, a plus, a minus. Category good, b plus, b. And the type is category. So we have 11 objects. You see its continuation. Only the top 5 are displayed, but we have a continuation of a plus. So pandas can differentiate between a plus and a minus grade because of these category representation. Now let's see. We have grades equal to df grades dot age type category. With the categories, let's say D, D plus, C minus, C, we change the order. Which order is which is different than the previous one, and we order true, and we print the head. So it gives us error because it does not see the difference between like which one got an unexpected argument. Categories. Um, Let me see. It's category. I think it should be category error equal to true. Maybe this one is error. Still the same error. Invalid argument category. So we have as type. I think we have not created a data frame here. We are creating data frame grade. So grade is here. But then we are looking for categories, which is not true because we have data here. And this data should not be here. This should work. But if I'm looking for the data as per my category that I define, that these are the categories, because here the order is different. It does not know, I mean, here in this order, it knows that a plus is greater than a, and a is greater than a minus, and so on. But here it does not know that order. I mean, d is not greater than d plus. So that's why we get error. Now, if I want to see the grades that are greater than C, so grades greater than C is giving us error. Unordered categories can only compare equality or non-equality. uh, what we can try, let's see, df grades. Okay, so you see all grades that are greater than C. So C plus, B minus, B, these are greater than C. Grades greater than C. So you see these are not greater than, sorry, these are greater than C. So it's false. And C is not equal to C. This is false. And for the others, it's true. Like for the D plus, D, and C minus. So D plus, D, C minus, and C plus. These are true. And the data type is Boolean. So we can perform different operation. Let me put an equal here. So you see it's for all C data, we have this true. Let's say we perform some more operations. So we load the data census.csv, and we create a data frame sum label equal to 50 with a set index state name with a group by label 0, census 2010 population, and then we aggregate, and then we take an average, and we take the cut operation with a df average and 10. So it prints the top 10 average data. So it's 10 categories. Is category. How many categories? 10. And this is in intervals. So we have one is this one is taken from here. This is the order data, and less than this one, and less than this one, and less than this one. So it converted the population, the average population of states into 10 different categories. So that was the scale data, which is very important because we do not always have continuous data. We have to deal with the categorical data. So it's very handy. It comes very useful when you are working, when you will be working on your project. So there is one more concept that is called pivot table. You have discussed pivot table in databases. In case you don't remember, go to your database book and try to understand what are pivot tables. Here I just give you the code of how to perform pivot table in pandas. So let's say we read the data, df is equal to pd.readcsv, cars.csv, and we print the df.head, and it's some year and make and model and size and kw, and a lot of data is here. What we can do, we are looking for df.pivot table values kw is here, index equal to year, this is index, and column is equal to make, and aggregate function np.mean. So what happens is these are the make years 2012, 13, 14, 15, and we are just printing the head. So we have the BMW and some NAN, and then we have some data here, Chevrolet and some other, all these models, their KW values are printed. We can have pivot table, values KW, index year, column make, aggregate function, np.mean, np.min, and margin equal to true. And here we have more data for these make year and mean values for these different models, and the min values for this different model. So It demonstrates that we can perform different aggregate function on this pivot table. So you can practice on this pivot table in your assignment, or you can go for some tutorial and see how different more examples can be executed on pivot table. Now this is one last topic, because often we deal with date data, and it's important that you understand how to convert in different types of date or timestamps. So let's import it again. It's already imported, no need for it. Let's do the timestamp. So if we want to do a timestamp, pd.timestamp, and we say, let's say 9 January 2016, and this is the time, so it will create a timestamp like this. You see how this format is converted to this format, and how this is converted to this format. Now there is a period, so pd.period, like how many days or months or years are passed since. So this is first 2016, so it's a month. You can do, I think it should print in year. And you can print a date, so this is a date. We can have the date time index. So let's say we have pd.series list ABC, and one timestamp is 9/1/2016, and another one is 9/2/2016, and the third one is 9/3/2016, and we print the date time index as. So you see there are three different dates with the ABC labels, and we can print the type. So the type is date time index. We can have period index. So let's say pd.series list def pd.period. This is 1, this is 2, this is 3, and we can print T2. So you see these are different period. Frequency is month, and date is dtype is object. We can know further about the object. It's a period index. Now we can convert to a date time. So let's say we have this data 2 June 2013, and then this is another data, and then this is another data, and then this is another date, all in different formats. So if we create a data frame, np.random ran integer 10 100, some data, random data is created with a column list A, B, and we print the data. So you see these different indices. You see we are using this D1 index. So the first index, second index, third index, and fourth index, and some random data is 4 by 2, 4 rows and 2 columns data is created. But this is not good when you are processing data. It's very difficult when you deal with different formats of date time. So what we can do, we have this nice function pd.toDateTime, and we do ts3.index, and we convert it to ts3.index, and we print ts, and you see is all in one format. So 2 June, so it's 6/2. August 29 is 8/29, and this format is already in this one, and this 7/12 is 7/12, like this. We can do this operation pd.toDateTime, and I enter 4.7.12, which is different than any formats that we discuss here, and we can do like this, and you see it is converted to the format. This one is day, so we put day first, equal to true, and you see how it converted to month and day and time. We can have time delta. So let's say we have pd.timestamp 9/3/2016 minus pd.timestamp 9/1/2016. The difference is 2 days. So 2 days, and no minute information, no time information is given, so it's a 0, 0. We can have pd.timestamp plus pd.time delta. So let's say today date is 9/2/2016. What will be the time after 12 days and 3 hours? 3 hours. Yes. So it will be 14, and this will be the time. Now working with dates in data frame. So let's say we have pd.date range 10/1/2016. Period is equal to 9. Frequency is 2-week Sunday, and dates. So you see, starting from 10/1/2016, we have a 2-week Sunday. So this is the first one, and the period of 9. So after 9 days, which is this one, and then this one, consider that we have a 2-week Sunday. So it gives you 9 period starting from this date. We can have pd.data frame count 100 plus some random integer, and then we take the sum, and count 2 is 120 plus some random integer, and let's print the df. So this is count 1, this is count 2, and some data. The same data that is given here. Now we can see the weekday names. So the weekdays are starting from Sundays. So this is Sunday, this is Sunday, this is Sunday, this is Sunday. It's starting from, because here the work is starting on. So we can do the df dot difference between these two, count 1 and count 2. No, it's the difference between dates. So you see, this is not a number because there is no previous data, and then it takes the difference between these two and the difference between these two, and so on, and all the differences are printed. So you can see some are positive and some are negative. We can do df.resample_m.mean, and this is, it shows data per month. And we can do per year df 2017 count 1 count 2, and df 2016 12 count 1 count 2, and df 2016 all data. And we can do as frequency w method is equal to f fill. We can perform this one operation, and plot. I think we will discuss plotting in detail, but this is just simple demonstration at how you can plot the data. You can import matplotlib.py plot as plot, and we do it inline to display it here, and df.plot, and it print the data of these different dates: October, November, December, and January, and then we have count 1 and count 2. We will discuss more about this plotting and charting in detail. Thank you very much.